How likely is it that Avi Loeb has found evidence of alien technology? A planetary scientist takes a closer look at Loeb's discovery of anomalous spherules and what they could be. Avi Loeb, a physicist from Harvard University in the US, has recovered 50 tiny spherical iron fragments from the bottom of the Pacific Ocean that he claims may be material from an interstellar alien spaceship. Loeb is linking his findings with the passage of a fireball in January 2014. The meteor was observed by sensors of the US Department of Defense that track all objects entering the Earth's atmosphere. It was recorded as traveling faster than most meteors and eventually broke up over the South Pacific Ocean near Papua New Guinea. Data on the object is held by NASA's Center for Near-Earth Objects Studies, CNEOs. The meteor's official name is CNEO 2014-0108, and it's also referred to as IM1 for the interstellar meteor. There's a very large scientific leap from observing a fireball to claiming that it is an alien spaceship. What is the evidence of which Loeb bases the claim, and how likely is it to be true? Oumuamua, the interstellar comet. We've already had at least one visitor from interstellar space, the comet Oumuamua. The appearance of 1L-2017U1, the official name for Oumuamua, was certainly an unusual event. The object was observed in 2017 as it was leaving the solar system. Its trajectory is different from the near circular orbits of the planets and elliptical orbits of comets. The comet's path was tracked back, with scientists discovering that it had come from well beyond the outermost fringes of the solar system. Scientists were excited but also intrigued. Although its shape was not captured on camera, the way that light reflected from it as it rotated suggests that it had an odd shape like a cigar when viewed side on, or a plate when viewed from the top. In a thoughtful article written in 2018, Loeb speculated that Oumuamua might be artificial rather than natural in origin, the product of an alien civilization. He suggested that we should keep searching for interstellar debris in the solar system. In pursuit of such debris, Loeb's team interrogated the CNEO's database, looking for objects with unusual orbital characteristics, and that's when they found CNEO 2014-0108, and based on its high velocity, suggested it was an interstellar meteor, giving it more manageable name of 1M1, Modeling the path of the fireball, Loeb identified a specific area of the South Pacific where he believed debris from IM1 would be deposited, and following a dredging operation in the area with a powerful magnet, he now claims to have found material from IM1. But what are the chances that he has found genuine interstellar debris at all, never mind a spaceship? Cosmic spherules. The metallic spherules that have been recovered are each about 0.5 millimeter in diameter. It is not impossible for them to be of extraterrestrial origin. Several previous expeditions have recovered spherules from space from the seabed. The first expedition to find such samples was HMS Challenger in 1872-76. Yes, 1872. Material dredging from the ocean floor contained many metallic droplets, described at the time quite accurately as cosmic spherules. Can you believe that? Droplets from space are spherical because they solidify from molten material torn from the surface of meteorites as they traverse the atmosphere. Subsequent expeditions throughout the 20th century have also found cosmic spherules at the bottom of the ocean, but it has become harder to identify them. This is because in 150 years since the Challenger expedition, the amount of pollution has increased on Earth. In 1872, the Industrial Revolution was in its infancy in Europe and practically non-existent in the Southern Hemisphere. Hence, pollution such as fly ash, waste from burning coal, and particles from vehicles was minimum. Many of these pollutants are also spherical in appearance and metallic in composition. Today, products from industrial processes and vehicles are everywhere, so without an actual analysis of the composition of the spherules and a comparison with analysis of meteorites and common terrestrial pollutants, it's not possible to identify any as extraterrestrial. Interstellar, but Loeb does not just think the material is from space, he thinks it's from interstellar space, arguing this could be the first time humans put their hands on an interstellar material. This is simply not true. We have an abundance of interstellar material on Earth. Some of it is almost certainly on the ocean floor, but not in the form collected by Loeb. The interstellar material to which I'm referring comes in several different varieties. It's well known by astronomers that the interstellar medium, the space between stars, is not empty, but contains several different molecules, many of which are organic, made up of chains or rings of carbon. A portion of these molecules got mixed up in the region of space where the solar system was starting to form. Stars themselves have also contributed material to the interstellar medium as they evolved or exploded as supernovas, and some of this material comes as tiny diamonds or sapphires, rare mementos of stars that lived and died before the sun was born. These grains become part of the dust cloud that collapsed to form the solar system and were eventually carried to Earth in meteorites. Alien spacecraft. Loeb's evidence for an extraterrestrial source for the material, never mind an interstellar origin, is rather shaky. He has found metallic spherules. For me and many others, to accept that these spherules are extraterrestrial, I'd need firm analytical evidence. What is their composition and what is their age? Can we rule out terrestrial pollutants? Can we rule out debris from extraterrestrial material from within the solar system? The first question about composition has been answered. Analysis of the spherules shows them to be mainly iron with a few trace metals. We know meteors from the solar system contain iron and nickel, echoing the relative abundances of these metals in the sun, but the spherules apparently contain negligible amounts of nickel, thus indicating that they are almost certainly not from meteors within the solar system. This does not, however, prove they are interstellar. It merely makes it more likely that they are terrestrial pollutants. The most convincing evidence would be to measure an age for the spherule greater than that of our Sun, which would identify them as interstellar. And that would be amazing, but it would not necessarily identify them as having an artificial rather than natural origin. I'm not sure what evidence would be sufficiently convincing for this. Maybe the autograph of the alien engineer who built the spacecraft. This is from Monica Gray, Professor of Planetary and Space Sciences, The Open University. This is published from The Conversation under Creative Commons. And this is on Unexplained Mysteries. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.